welcome back to our channel. Today we are going to solve this problem number 17. The given problem is a 318 microfarad capacitor is connected to an 230 volts supply with 50 Hz. Let's first draw the diagram. Okay, so now here you can see here we have an sinusoidal supply is given to an capacitor. The value of the given capacitor is 318 microfarad capacitor. So when you convert into farad, this is 318 into 10 to the power minus 6 farads. This is excited with an RMS voltage. The given voltage, the 230, is generally the RMS voltage, and with a frequency of F is equal to 50 Hz, it is excited. Okay, so he is asking us first to find out the capacitive reactance. The formula for capacitive reactance is minus J XC ohms, that is equal to minus J XC can be written as 1 by omega C ohms. Okay, this can be written as minus J 1 by omega value is 2 pi F into C value is how much? 318 into 10 to the power minus 6 farad. If you substitute, then the value is transformed into 10 ohm, and you have the polarity of minus 10 J. Okay, therefore the capacitive reactance, the capacitive impedance is given by R minus J XC, or the capacitor is given by R is equal to 0, and minus J XC value is minus J10 ohms. So but here is asking us to find out RMS current. How to find out IRMS? IRMS is equal to V by Z. Okay, so the value of RMS voltage given is, you can see here, the supply voltage given is 230 at an angle of 0 divided by the value of ZC is, so here you can write down in polar form. This polar form I can write down 10 at an angle of minus 90. So this is in rectangular form, and now this is in polar form. Then you are going to get 10 at an angle of minus 90. So this is in polar form. We can perform the division and multiplication of polar form. The resultant current, so 230 divided by 10, you are going to get 23, and this minus 10 goes to the numerator, you are going to get 90. This is the RMS current value. Okay, so but we need to find the instantaneous quantity. How to write down the instantaneous quantities? V of t equal to Vm sine omega t. Okay, and how to write down I of t? I of t is equal to I maximum into sine of omega t plus theta. Here is a pure capacitor, then here you are going to have theta equal to pi by t. So now let's try to find out. So here the maximum value we require, but in the question what is given, RMS quantity is given. In the question what is given is RMS. So how to link the both is, the formula of Vrms is equal to Vm value divided by root 2. Okay, so the RMS value given is 230, that is equal to Vm by root 2. So from here you are going to get the value of Vm is equal to root 2 into 230 volts. When you do it with your calculator, so root 2 into 230, you are going to get it as 325.269 volts. Similarly, here I require maximum current, but in the question what I have obtained, this is in the polar form, R at an angle phi. Okay, so the polar form I can write down it as IRMS is equal to Im value divided by root 2. Okay, so IRMS is how much? Is nothing but 23 into root 2, that is equal to the value of Im. When you multiply 23 into root 2, then you are going to get yes 32.52 amperes. Okay, so now let's try to substitute in the equation. In the instantaneous voltage equation, V of t is equal to, what is the maximum value we obtained? This is 325.26 sine of omega t. What is the value of omega? 2 pi f. F is how much? 50 t. And the value of instantaneous current I of t is equal to IRMS. IRMS value is how much? 32.52 into sine of omega. So omega can be written as 2 pi f. The given frequency is how much? 50 t plus pi by 2. So this is the standard form of writing v of t as well as I of t. So these are the instantaneous quantity. But when you write down the RMS quantity, VRMS is equal to 230 at an angle of 0, and the RMS current you are going to get it as IRMS is equal to, so what is RMS current you have obtained, which is 23 at an angle of 90 degrees. Okay, so when you do it, this is the form R at an angle phi. Now let's try to draw the phasor diagram. Okay, so when you draw the phasor diagram, we are going to take the voltage as reference, V at an angle 0, where this is called as the reference, and here you can going to have the current of 90 degrees. Okay, so the magnitude of the voltage is 230 volts, and the direction of current, which is nothing but whenever it is rotating in counterclockwise direction, then you are going to get plus 5. Okay, so here the angle made is nothing but plus 90 degrees, and the current here, the magnitude you are going to get it as 23 ampere. So therefore this is 23 at an angle of 90 degrees. Okay, so this is V at an angle 0. So this diagram is called as phasor diagram, and it is valid, and when you draw it only for in the form of polar form. So in the polar form, we have only the RMS quantity. So here, this is also RMS quantity, and this is also the RMS quantity. This is how to draw the phasor diagram for the given system, and how to find out V of t as well as I of t, and RMS value as well as capacitive reactance and the total impedance. If you feel my explanation is good, please like the video and share the video with your friends. And if you are watching my channel for the first time, subscribe to my channel. If you have any doubt, let me know in the comment section. And if you are watching the channel for the first time, go to YouTube, just search KV Tulasi Ram. You get this